Okay, so your first one is butanoic acid. What would you call the second one? Remember, this is carbon 1. Say it, Reese.
Is it 2-methylpropanoic acid?
2-methylpropanoic acid. Okay.
So aggressive.
So now esters, jump it up a notch. What we see here is we see this same pattern. A double bonded O going off to an O, but instead of being a hydrogen group, we see another carbon. R's represent a functional group, and typically it's attached to a carbon. So there's a carbon here and a carbon here. R with a tick beside it means R prime. It's the secondary line. Okay? So esters have a pattern of RCOOR prime. And so you have to have this carboxyl starting point. Okay? So an ester is made up of two parts, an acid and an alcohol. And then we use it to name our esters. So R going up to a carbon group. So this is we see as the beginning of our carboxyl group, only now we're going to another carbon or another functional group. So this part here this is our acid component. And this part here is our alcohol component. Okay? So naming. Naming doesn't get too much different. We follow the same pattern that we've established right from the very beginning of doing alkanes. So the longest carbon chain that's attached and includes the carbon double bonded O group is the acid part. So this is the R. And then the root now also includes any side groups coming off that chain. Okay? It'll make sense when we see it. So you use the same rules before for naming. So you remove the oic acid. So if we were looking at pentanoic acid, which is 2, 3, 4, 1, 2, 3, 4, 5 with the double bonded O, and then our OH, right? Now we're going to have our, instead of this H, we're going to have another carbon group. But this starts our numbering. So 1, 2, 3, 4, 5. So we still had the pentanoic acid part, but this part here gives it this extension. So it's pentanoate. Okay? I know it seems overwhelming, but it'll make sense. Have faith. So, to form the prefix, consider the alcohol part of the ester, count the number of carbons in that chain that's attached to the oxygen in the alcohol part, that's the prefix. Okay? So let's see what this looks like, so that we're not panicking. Too late? Okay. Okay? So what we see here is we see the R group, because it has the double bonded O. So that's our R group. Here's our O, and here's our R prime, right? An ester is R, O, R prime. So wherever you see the double bonded O, put your R. Then put your O under your O, and then put your R after your next group. I know that at the beginning it says RCOOR prime, but this is what I find works best for me. I put the R underneath the double bonded O. ROR prime. So this is how many carbons with this acid? 1. So this is methanoic. Methanoic acid, right? So this group here has how many? The R prime has how many carbons in it? 3. So 3 carbons is propyl, right? So this becomes our prefix. And then our R group becomes our suffix, or our root.
So we don't need any numbers with that?
Not in this particular one. There's no side chains in this one, right? And the 1 always starts with this carbon. And this here is your key that you're dealing with an ester. OATE. Let's look at another one. Good. This guy. So where is our double bonded O? Right here. So this is our R. This is our O. So this is our R prime. Okay, start there. Just start with that, RO, R prime. Now in our R group, we still need the longest chain, including this double bond. So we have 1. Don't forget, there's a carbon here. That people will make that mistake time and time again. 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is our longest chain this way here. That includes our double bonded O. So we have 5 carbons, right? Don't forget. 1, 2, 3, 4, 5. So what do we call that? R group. Pentanoic acid, right? And what do we call this guy here?
How come this time at that side, like the chain is the pentanoic acid? Because last time, the R, oh I see, the O was on the other side.
The O's on the other side. That's why I always start with your R, O, R prime. So then this group is what? How many carbons?
1.
Just the 1 right there. This is our alcohol group, right? So this is methanol. Right? And we see that we have 1 side chain. What do we call that side chain? Ethyl. Okay? You have to break it down into baby steps. Identify each of the different parts. Then you can combine. If you try and do it right off the bat, you're going to be overwhelmed. Okay? So we know that because we have a pentanoic acid and we have a methanol and RO-R prime pattern, we have pentanoate. This becomes a methyl group. Okay? So our prefix is going to be methyl. Always start with your alcohol. Then where do we find our side chain? 2. Methyl 2-ethyl pentanoate.
Why is it pentanoate not pentanoic gas?
Because it's an ester. It's an ROR prime pattern. Okay? So prefix, side chain, root. Okay? So let's go backwards from the name. It's not that complicated, you just gotta break it down. Okay? So here we see butanoate. So this is our root. This is 4. And here's our ethyl, which is our ethanol. So there's our alcohol group. And then these guys in here are our side chains. Side chains always, always, always go on the acid one, the ROR prime one. So let's follow that pattern. ROR prime. So R, and this is R prime. So we have butanoic. So C double bonded to an O. How do I want to draw this? No, I flipped it on myself.
Can we that R under the 4 butanoic? That's not part of like the. Okay.
Well, butanoic acid looks like this, right? 2, 3, 4, double bonded O, and there's our OH, right? That's what butanoic acid looks like. Ethanol looks like this. 1, 2. Okay? So this part here is our butanoic. So we have the double bonded O. 2, 3, 4. I'm just going to leave that one alone. And then we have our alcohol group, which is where our O comes into play. Right? This is our R, O, and then R prime. And R prime says that we should have 2 carbons. Okay? R, O, R prime. And on our side chains, we have 3,3-dimethyl. So here's 1, 2, 3, 4. So here we have a C, and here we have a C.
So with the O on the top one, is that like the bond between like the carbon and the double O and the OH? Is that where the O goes on the carbon?
Right here. Start over again.
No, like at the top.
This one here.
Yeah, where is that O?
Which O? This one?
No, the bottom.
This one?
That one above the O.
This is R, R, O, R prime. And this is that O right here.
Oh, okay.
What happened to the H?
Yeah.
DH. This is just if I wrote butanoic. Right?
But because it's
I wrote butanoic there. That's butanoic. If you want the R prime, whoops. If you want the R prime, you take the H off and you move this to an R prime group. The alcohol loses the hydrogen and the carboxylic acid.
And we know that.
We're going to get into reactions and it'll make more sense, but for now this is the formation. Okay? Is that you take your butanoic. We start reacting carboxylic acids and alcohol groups, and then you can see we do all kinds of reactions now. Okay? So there's hydrogens here. Okay? Clear as mud?
Yeah, pretty much.
Perfect. On that note, I'm going to leave you guys to work through the questions that are at the bottom of your carboxylic acid page, page 570, number 33 and number 34. And then the ones that are at the bottom of this page, page 572, number 37, number 38.
Wait,
Okay?
what?
Can we start going over the
33 and 34?
Sure.
Do we